So hello dear students, welcome to the session. On behalf of Meritnation, I welcome all of you to the session of NEET Bytes. And today's topic is thermodynamics. So hello Aditya, hello Meghna, hello Sahil, and hello Shagun. So welcome everyone in the session. I hope all of you are doing good. So now let's start with the questions. So today we'll basically talk about the first law of thermodynamics. Hello Ayush. Okay. Hello Satvoholic. Okay, so everyone, welcome. So the first thing is the first law of thermodynamics. What is that? What is the first law of thermodynamics? Any idea? See, if delta Q is the amount of heat, okay? So this amount of heat contributes to two things. One, work done, and one, change in internal energy. Okay. Okay. And this one is work done. Okay. So delta Q is equal to delta U plus delta W, right? So this is the first law of thermodynamics. If heat is absorbed, we say delta Q is positive. If heat is given out, we say delta Q is negative. Similarly, we say that the work done, the internal energy, the change in internal energy is positive when temperature increases. Okay, and delta U is negative when temperature decreases. Similarly, for when the work is done on the gas, we say the work done is negative. And the vice versa, we talk about for positive work done. Now let's see this question. 1 mole of an ideal monatomic gas undergoes a process described by the equation PV raised to power 3 is equal to constant. The heat capacity of the gas during this process. So dear students, this is the question that came in NEET 2016. And this is what type of process is that? It's basically polytropic process. Okay, polytropic process. So in polytropic process, PV raised to power n is constant. Okay, so how do we find the specific heat or the heat capacity for this polytropic process? Simply we write C is equal to CV plus R by 1 minus N, where N, let's take it capital N because you may get confused with a number of moles. Okay, so let's say it's capital N, the power raised to V. So this is the way, this is the formula by which we find the specific heat capacity. Okay. So in this question, now what is the value of CV? What is CV? See, CV for monatomic gas is equal to 3 by 2 into R. This is for monatomic gas. Okay. And in this question, this N is equal to 3. So this means C is equal to CV, that means 3 by 2 into capital R plus R by 1 minus N. So N is equal to 3 here. So 1 minus 3. This is equal to 3 by 2R minus R by 2. So this is equal to your R. So students, you can see which option is correct here. Option B is correct. Okay. So Meghna, this is the equation for polytropic process in which PV is to power n is constant. Okay. So now let's move forward. Now, in this question came in NEET 2018. What is the question? The question says the volume V of a monoatomic gas varies with its temperature T as shown in the graph. The ratio of work done by the gas to the heat absorbed by it when it undergoes a change from state A to state B. First of all, dear students, please tell what type of process is the gas undergoing? Tell me. What do you understand by the graph? It's VT graph and it's a straight line passing through a region. What type of process this gas is undergoing? Tell me. Anyone? Just please try this. Isobaric. Very good. Who's there? Aditya. Very good, Aditya. The process is isobaric, in which pressure is constant. Because the gas, you see, because of this curve of Vt is passing through origin and it's a straight line, so that means pressure is a constant value. Okay, so it's an isobaric process. So what is delta Q for isobaric process? Delta Q for isobaric process is equal to NCP into delta T. Okay, NCP into delta T, where N is the number of moles and Cp is the specific at constant pressure. Okay, and delta T is the change in temperature. So what type of gas is that? It's monatomic gas. So what is the value of Cp for monatomic gas? Cp for monatomic gas is equal to 5 by 2 into R. This is the value of Cp for monatomic gas. Okay. So next thing, we have to calculate the work done. Okay, the work done. So okay, first of all, we can write delta Q as N into 5 by 2 R into delta T, right? The delta T. Similarly, we have work done. Okay, work done. So what is work done? Work done is equal to P delta V. Okay, P delta V. So from here you can see, as the pressure is constant, we can say P delta V is equal to NR delta T, right? Because pressure is constant, because the work done will be P2V2 minus P1V1, and you can see it will become nRT2 minus nRT1. So simply we can say it's nR delta T. That's the work done, right? So what we have to find? We have to find the ratio of work done to the heat absorbed. Okay, we have to find the ratio of heat absorbed, work done and heat absorbed. So delta W by delta Q we have to find, and delta W is equal to nR into delta T divided by it's N into 5 by 2R into delta T. So N and N can be cancelled, R and R can be cancelled, delta T and delta T can be cancelled. So this becomes 2 by 5. So which is the correct answer? A is the correct answer for this question. Now let's move forward. So this question came in 2015. 1 mole of an ideal diatomic gas, okay, it's a diatomic gas, undergoes a transition from A and B along a path AB as shown in the figure. The change in internal energy of the gas during the transition is. We have to find the change in internal energy. What is the formula for that? Delta U is equal to NCV delta T. So what is the value of CV for diatomic gas, students? What is the value of CV from diatomic gas? Tell me. CV for diatomic gas is 5 by 2R, right? 5 by 2R is a CV for diatomic gas. Beta, that's CP. Okay. Smruti, that's CP that you're writing. Okay. So CV is equal to 5 by 2R. So now NCV delta T is a change in internal energy. So we can say delta U is equal to N into, now N is equal to 1 here. So 5 by 2 R into delta T. So TB minus TA. So we can replace TB and TA from this graph. How we can do that? We know that PV is equal to nRT, right? So this implies T is equal to PV by nR. So this means TB is equal to PB into VB by R, and TA is equal to PA VA by R. Okay. So TB is this and TA is this. So put the value, delta U is equal to 5 by 2 into capital R multiplied by PB into VB by capital R minus PA into VA by capital R. So from here we can see R and R get cancelled out. So delta U becomes 5 by 2. Now what is the value of PB VB? From the graph we can catch the value. You see it's 5 into 10 raised to power 3 Pascal for A, and volume is 4 into 10 raised to power, sorry, only 4 meter cube. So what we can write here, this product of that for PBVB, for PB, pressure is 2 into 10 raised to power 3 pascals, and volume is 6 into 6 meter cube. So this becomes 2 into 10 raised to power 3 into 6 minus PAVA. So it's 5 into 10 raised to power 3 multiplied by, what is the volume? It's 4. Okay. So if you calculate the value, what do you get? You get minus 20 kilojoules. So that's the answer. B is the correct answer for this. Let's move forward. Figure below shows two paths that may be taken by a gas to go from state A to state C. Okay. So here, if you see, there's a PV graph given. So a gas goes from A to B and then B to C, or it can go from A to C directly. So there are two different paths. In process AB, 400 joules of heat is added to the system, and in process BC, 100 joules of heat is added to the system. The heat absorbed by the system in the process AC will be. Okay. What we have to find? In this question, we have to find the heat added or heat absorbed by a system in process AC. Okay. In process AC, we have to find the heat. Now, how to find the heat? The first thing that you should know that delta U, it does not depend upon the path. It only depends on initial and the final conditions. Okay. So we can say delta U along AC is equal to delta U for AB plus delta U for BC. So main thing is initial and final position. Initial position is A and final is C. So whether you go like this, whether you go like this, so it's the same thing. Okay. So Firstly, we'll find the value of delta U. Okay, firstly we'll find the value of delta U for A to C. For that, we'll find delta U AB and delta U BC, because we don't know anything about AC. So what is given in the question? It is given that in process AB, 400 joules of heat is added to the system. Now, students, can you please see that? Can you please see what type of process is AB? Tell me. It's a state function, Shruti. A state function. What type of process is AB? Tell me. From A to B, what type of process is that? What is constant? What is the constant? What is constant? Smriti, I have told, no? It's state function. It's isochoric process. A to B is isochoric process. What is the work done in isochoric process? In isochoric process, volume is constant. So that means delta V is equal to 0. So delta W, that means work done is also 0. That's clear to everyone. So from A to B, work done will be 0. Okay. So if you write first law of thermodynamics, delta Q is equal to delta U plus delta W. So we can say delta W is equal to 0 for A to B. Okay. So it's given that delta Q A to B is how much? It's equal to 400 joules. So delta U A to B is 400 joules, right? So this thing should be clear to everyone. The delta U A to B is equal to 400 joules. First. Now talking about BC, what type of process is BC? What is constant in BC? What type of process is BC? It is isobaric process. In this process, pressure is constant, right? In this process, pressure is constant, and delta Q, yeah, very good. Delta Q BC is given as 100 joules, and that is equal to delta U B to C plus delta W B to C. So change in internal energy from B to C is delta U BC, and delta W BC is the work done from B to C. So we have to find delta U BC. We can find delta W BC simply seeing the graph. Simply seeing the graph, we can find the value of delta W BC. Okay. How can we find the work done? Work done is equal to P delta V. So we can see pressure is constant. Pressure is constant. So simply multiply P with delta V, you will get the value of work done. Okay. So what is the value of P here? It's 6 into 10 raised to power 4. 6 into 10 raised to power 4 is the pressure. So P delta V for BC, P delta V for BC is equal to, it's 6 into 10 raised to power 4 multiplied by, it's 4 minus 2 into 10 raised to power minus 3. So what does it become? It becomes it becomes 80 joules, 120 joules. It becomes 120 joules from here. So delta U BC plus 120 joules is equal to 100 joules. So this implies delta U BC is equal to minus 20 joules. That's clear to everyone. So now adding both of them, adding delta U AB and delta U BC will get delta U AC. So delta U AC is equal to delta U AB plus delta U BC. Add them, 400 minus 20 is equal to 380 joules. This is the value of change in internal energy for process AC. Okay, this is the delta U for AC. Now, how to find delta Q? How to find delta Q? delta Q AC is equal to delta U AC plus delta W AC. So delta U AC we have got to be 380 joules. Now how to find the work done? How to find the work done? Now for the process AC, you can find the work done by simply calculating the area of this trapezium that I'm showing right now. This trapezium that I'm right now showing you. Find the area of this trapezium. That's the area under PV curve. Find the area of that. You'll get the value of work done for process AC. Okay. So now for process AC, what is the work done? Simply find the area of this. So how to find the area of this trapezium? This is actually a trapezium, and that's equal to half into sum of parallel sides into altitude. So what are the parallel sides? Now one parallel side is 2 into 10 raised to power 4, and one is 6 into 10 raised to power 4 pascals. So you can simply say delta WBC is equal to, it's equal to 1 by 2 into, now 6 plus 2. Okay, 6 plus 2 into 10 raised to power 4. And what's the altitude? It's 2 into 10 raised to power minus 3. 2 into 10 raised to power minus 3. Okay, so when you find a value, you find its value, you'll get 80 joules from here. Okay, so delta Q AC will be equal to 380 plus 80 joules, and that will become 460 joules. So the correct answer for this question is C. So I hope everyone is getting this. Now last question. A gas is taken through the cycle A to B and C to A as shown in the figure. What is the net work done by the gas? So to find the net work done, you have to find the area of the enclosed, sorry, the area enclosed between this curve. Okay, this enclosed area you have to find. Simply you can say it's a triangle. So half into, what is the base? You can see it's 7 minus 2, it's 5 into 10 raised to 5 into 10 raised to power minus 3. Okay, 5 into 10 raised to power minus 3. And what is this change in pressure? It's 6 into 2, 6 minus 2, that means 4 10 raised to power 5. Okay, so from this you can calculate the value to be 1000 joules. So the correct option is B in this question. So dear student, thank you so much for attending the session. So to know more about how Meritnation can boost up your preparations, you can see this link that's mentioned in the description also. And one more information I would like to give you is that about our NEET Catalyst course. So you can join NEET Catalyst course. We have such features like we have AITS, that are actually your real examination based papers, and there are 4-part tests and 13 full tests, and all are computer based, and full syllabus sample paper will be also given to you, and previous year papers also. So this will really help you to boost your preparations. And we send some daily set of questions, physics, chemistry, bio. And after, if you join this course, after every AITS we have sessions to help you out how to solve each and every question. So you can see the description as the link is given. Okay, so thank you so much. So all the very best. Thank you.